let's try to analyze this hash family, right. So basically we want to understand what is the chance that if I take 2 points they collide, right. So collision happens. Collision is nothing but if you have x and y, let us say in RD, and if I have some fixed h from the hash family. So, if h of x equals h of y implies collision, that is both both x and y are mapped to the same bucket, that is all it means, right. So, collision means they get mapped to the same bucket, right. So, that is all, that is just the standard terminology for this. Now, what I want to then argue is what is the probability. So, this is my question that I am then interested in is what is the chance of a collision happening, right. So, if I take, let us take any x and y and then ask what is the chance of a collision happening, right. So, what is the chance that if I draw h, small h from capital H, which is the family, according to this procedure that I described earlier, where A and B are randomly generated, and once they are randomly generated, that corresponds to a function which is what I have picked from script h. What is the chance that h of x equals h of y, right. So, let us say if we fix x and y in RD, any x and y, and then I want to argue what is the chance that h of x equals h of y. Okay. So, why do I care about this? Because if I somehow am able to say that this collision probability depends on the distance between x and y, that is, if the x and y are close, then the collision probability is large. If an x and y are further apart, then the collision probability is small. That is, if they have an inverse relation, then I kind of have what I want, right. So, of course, the RC P1 P2 have to be specifically figured out, which is okay, but at least the property that I am looking for is that the collision probability monotonically increases with decrease in distance, right. So, for x and y, right. So, it's x and y can be anything. If I make x and y closer to each other, the collision probability should increase. If I separate them apart, then the collision probability should decrease, right. So, basically that's what I am that I am looking for, right. So, in this expression, but let us see if that happens. So, we won't completely prove this, right. So, this is a proof sketch, or at least we'll go till a point and then I'll kind of not do the whole proof, but I'll give enough for us to convince ourselves what's going on here. Okay, so let's write this down again, right. So, h in h of x equals h of y. This is the collision probability. Collision probability is what we want to understand. Let's break this down. A has some randomness, B has some randomness. So, let's write this as the probability of A coming from some Gaussian with mean 0 and identity covariance in D dimension. That is my A, that is how I generate A. And how do I generate B? B is uniform in 0 comma W. Then I am asking the question h of x equals h of y. Well, what is h of x? H of x is A transpose B plus, sorry, A transpose x plus W, okay, A plus B by W's floor. Y, h of y is A transpose y plus B by W's floor. These two things have to be the same, right. So, that's the question that we are asking. I mean, what's the chance of this happening? So, there are two sources of randomness, one is A, one is B. We will analyze them separately because they are independent, you can analyze them separately. So, what we are going to ask is, let us say I fix some A in D dimension, right. We will worry about the probability of A a little later. Now, let's ask the question, what is the probability of B that over B's randomness, that A transpose X plus B by W equals A transpose Y plus B by W. Okay. So, now because A is fixed at this point, right. So, because we are thinking of A as some constant at least at this part of the analysis. So, let us give it some name, right. So, I do not have to carry A transpose X, A transpose Y separately. Let us call A transpose X as some U, A transpose Y is some V. Then essentially what I am asking is probability over B's randomness, U plus B by W's floor equals V plus B by W's floor. I have not done much, I have just renamed things. I am going to do one more renaming. Let us say I also define delta as just A transpose X minus Y. That is just the difference between A transpose X and A transpose Y, which means that V plus delta, right. So, this implies V plus delta is basically A transpose Y plus A transpose X minus Y, which is just A transpose X, right. So, V plus delta is U. So, I can then say that this guy is probability V plus delta plus B by W's floor equals V plus B by W, right. So, this is basically what I am asking for, right. Now, so this is a B can take any value between 0 and W. So, that is uniformly between 0 and W, but we will come to that in a moment. So, I am going to think of this as whatever the value of B, right. So, B can take any value between 0 and W, whatever the value of B is. So, let us think of this as follows, right. So, I have the real line and there is some, I am cutting it at width of W, and now I get, let us say V, and then some B gets generated, I get V plus B, right. So, for the moment let us say this is V, this is my V, okay. Now, V plus B can be anywhere between 0 and W, uniformly anywhere between 0 and W. So, which means that V plus B can be anywhere uniformly between V and V plus W, right. So, this is V plus W, V plus B can be anywhere here depending on what B is. B is some number between 0 and W. Now, let us say there is some number that gets generated, and for the moment let us say B was this, right. So, B was this amount. So, this is V plus B, right. So, this is V plus B. Now, if I divide by W, then it means that I am going to get, I am in this box, right. So, this is box 1, this is box 2, this is box 3, this is box minus 1, minus 2, and so on and so forth, right. So, if this value is 0. So, if I divide V plus B by W, and then I take the floor, so I am going to get, it is going to be in this box. Now, that would be this, I mean the box number corresponding to the right hand side. Now, now let me ask for what value of delta do I even stand a chance to be in the same box, right. So, if delta is, so basically the left hand side is V plus B plus delta by W, right. So, I can write that as, I can write that as V plus B by W, which is the previous guy, plus delta by W, and then the floor of this. This is just V plus B by W, the floor of this, right. So, if delta, right, so delta, remember, is A transpose X minus Y. It can be both a positive value or a negative value, but if the absolute value of delta is more than W, which means that when I divide it by W, I am adding one extra unit, right. So which means that I might, so I will go either to the right hand side box or to the left hand side box, right. So if the absolute value of delta is more than W, right. So V plus B is here. So if the absolute value of delta is more than W, so then I would have jumped to either this side with more than W, or I would have jumped to somewhere here, if to the right hand side box, depending on whether delta is positive or negative. If the absolute value is more than W, then I will not be in this box. Now it does not depend on where V plus B is, right. So no matter where V plus B is, it will go to some box, but then if the delta's value is, absolute value is greater than W, the width, right. So no matter where in the current box V plus B is, if I add more than the width in absolute sense, it is going to either go to the right hand side or to the left hand side, right. So which means that the collision, for collision to happen, then delta has to be within absolute value of delta has to be within W, right. So that is the first observation, right. So observation, for collision to happen, because we are caring about collision probability, for collision to happen, absolute value of delta must be less than W, right. So otherwise it might jump boxes either to the right hand side or to the left hand side, independent of what B's randomness is, because B is added to both left hand side and right hand side, right. So whatever that random value is, it gets added to both left and right, which means that we are only measuring V plus B by W, and then am I jumping one unit to the left or right? Well, if I need some chance that I do not jump, then it means that delta has to be less than W. Okay, so this is observation 1. Now that is not just enough, right. So delta being less than W is a necessary condition, it is not like a sufficient condition, right. So that the sufficient condition depends on what exactly B is, right. So we will talk about that. So now so let's switch the roles of, not switch the roles, let's switch the analysis a little bit. So we still have these boxes like this in the intervals, this is interval 1, interval 2, 3 and so on. Let us say we have V, which is somewhere here, sitting here, this is V, and now I have a delta. So for now, let us say delta is positive, similar argument will hold if delta is negative also, and I have V plus delta to be this guy, right. So let me use a different color for that. Let us say this is so this is V plus delta, and now I want to know what happens if I so when will I not so how much, so basically what I want to ask is, so now I am adding B to this guy, right. So and I want to know by adding that how much leeway do I have for B, right. So to add B here, right. So so this V plus delta, now if I add B to it, so I want to know when will that so which is the region where B can be added, right. So that is the question that I am asking, right. So B can be any value between 0 and W, it is uniform between 0 and W in general, but so let us say if I after added, so if I add B to V and if I add B to V plus delta, they should both land in the same box, right. So that is what I really want B to satisfy, right. So which means that if B was W, let us say in this case, right. So now I know, let us say delta is within, absolute value of delta is within W, because if that does not happen, then I do not have a chance that they are going to be in the same box. So let us say absolute value of delta is within W. Now the question that I am asking is how much can B be, right. So V plus B can maximum be W, but then the delta is already taken up by the left hand side, right. So, there is no delta here, there is a delta here, right. So, the only remaining thing that B can be is, it has to be between 0 and W minus delta, right. So, only if it is between 0 and W minus delta, then there is some chance that, I mean, that's the chance, that's the only time when these two guys will land in the same box, right. So, then what will happen is that, whatever this B is something like between 0 and W minus delta. So, the delta and delta will kind of cancel out, right. So, this is between, whatever, I mean, it can't cancel out directly because it is uniformly between 0 and W minus delta. So, you are in the same box, right. So, basically you are not switching boxes. So, with respect to V plus B by W and V plus delta plus B by W, right. So, that is the remaining thing. Though B is uniform between 0 and W, given a delta, then B can only take values between 0 and W minus delta. But then we are actually drawing, we do not know what delta is a priori, because delta itself is a random quantity. So, we are drawing B at random and that B better satisfy between 0 and W minus delta. So, what is the chance that a uniform random variable between 0 and W takes a value between 0 and W minus delta? Well, it is, you have 0 and W is the complete width, but then you want it to be between 0 and W minus delta. So, what would that chance be? Well, it is uniform, right. So, that would be just W minus delta by W, the entire length by the length where you want it to be. So, which is like 1 minus del by W, because mod del is anyway less than W. So, this is still okay, right. So, basically then what we are essentially saying is, if I fix A, then the probability, I will come back to the old color, the chance that over B's randomness, h of x equals h of y given a fixed value of A is 0 if absolute value of delta is greater than or equal to W, right. So, or absolute, yeah, that is true. And it is, what is the chance that if delta is less than W, then what is the chance that I am still in good shape? Well, even after adding delta, I mean, I only remaining W minus delta for B's possibility. So, that happens with probability 1 minus del by W, right, absolute value of del by W actually, right. So, del can be negative. So, we are thinking of it as absolute value of del by W, yeah. So, this is the chance that if I fix A, then what is the chance that a collision happens if I draw B at random, right. So, if I fix A transpose x and A transpose y are fixed, which means delta is fixed, which means that delta is going to eat up some space in, that V plus delta part. So, the remaining part is what is left for B, which is 1 minus delta by W, right. So, now we will bring in V's randomness or rather A's randomness as well. So, now the question then is delta, right. So, which is, what is delta? Delta is A transpose x minus A transpose y, which is A transpose x minus y, where A is some Gaussian with mean 0 and covariance I. We have already seen what random variable this is, right. So, this is just a Gaussian with mean 0 and variance equal to basically, the variance would just be the length squared of x minus y, right. So, this is something that we saw when we are doing JL, and that is why JL kind of works in some sense, right. So, because you can think of JL as estimating this length squared using multiple such dot products. So, then we will ask, right. So, what is the chance that over both the randomness of A and B, h of x equals h of y? Well, now this delta itself is random. A's randomness is comes into picture only via delta, because A transpose x minus y is what matters. So, absolute value of that is what matters. So, this is the probability, right. So, this I can write this as probability over A Gaussian with 0 ID, or equivalently I can write this as probability over delta as Gaussian with 0 norm x minus y squared, probability over B uniform 0 to W h of x equals h of y, right. So, so this we have computed. So, one way to summarize this probability would be to say that this is the max of 0 comma 1 minus del by W, right, because if 1 minus this is true only if absolute value of del is less than W. If the absolute value of del is greater than W, then this quantity is going to become greater than 1. So, this max will compute to 0, otherwise it will compute to 1 minus absolute value of del by W, right. So, which means we can write this whole thing as del can take any value between minus infinity to infinity. So, I am going to do an integral over minus infinity to infinity, so you can think of it as given some value of del, what is the chance that the collision happens is just max over 1 comma 1 minus, let us call del as t here as a running variable, absolute value of t by W. But what is the chance that, so this is like probability of B given delta into probability of delta, right. So, and then I am integrating it over all values of delta, I am running it, thinking of delta as t here. So, this is probability of h of x equals h of y given delta, right. So, given a particular value of t, and then I want to write the probability of t itself, which is just the density of t because it is a Gaussian. So, and we know what that is for a for this, which is just 1 by square root 2 pi. I can write this as norm x minus y e to the minus t square by 2, well the distance is norm x minus y squared, right, dt. Basically this is, think of this as probability of t. So, basically I am integrating it over all values of t minus infinity to infinity. So, this whole thing is just probability of the collision happening. Yeah. So, this is the probability, it is not, I mean this is the collision probability. Now, so there is no closed form solution to this, right. So, this you can compute this numerically and so on, because you can generate t's at random and then compute for a fixed value of W, it is not too hard, right. So, you can generate a lot of t's at random, Gaussian values at random with mean 0 and variance norm x minus y squared for any x and y, and you can compute max of 0 comma 1 minus absolute value of t by W, average them out. So, that is going to give you better and better values for this. But as you can see, right, so there is this dependence on x minus y, and using that one can argue, and this is why this is not like a complete proof, one can argue this is monotonically decreasing function of norm x minus y. In fact, this guy can be taken out here, right. So, this is just, you can write this as and also you can use the symmetric nature of Gaussian to say this is this absolute value can also go, this can be written as 2 times, I mean on both sides, and minus infinity to infinity, also rather 0 to infinity, max of 0 comma 1 minus t by W e to the minus t square by 2 x minus y squared dt. Yeah, so the thing to notice is that we can evaluate this expression numerically, but then this also goes down with norm x minus y, right. So, or rather not goes down. So, this is inversely proportional to norm x minus y. So, in other words, as norm x minus y becomes smaller and smaller, the collision probability becomes larger and larger, right. So, why is that helpful for us? Because for us, remember our hash family was, we need to argue that hash family is RC P1 P2 sensitive. So, P2 remember is just the is just the probability of a collision happening when norm x minus y is some value CR, and P1 is the probability of a collision happening when norm x minus y is just R, right, and R is some value greater than 0, C is some value greater than 1, which means that CR is going to be greater than R. But now we are just argued that this collision probability function f is monotonically decreasing function of the norm. So, which means that if I increase R, then the probability is going to decrease, which means that we will have P2 to be less than P1, 0 of course less than P1 less than 1, because these are probabilities. But what we have managed to argue is that if I mean just because of the fact that this is inversely proportional to the norm, the collision probability is inversely proportional to the norm, it means that we have an RC P2 P1 family. What exactly these P1 P2 RC values are, well, that's where in practice you will have to do a lot of tweaks to this algorithm, not tweaks per se, but then you will have to use this algorithm in an intelligent fashion, which we will come and discuss next time. But just to summarize where we are today, all we have said is that we wanted a family of hash functions which is RC P1 P2 sensitive, where you want P1 to be greater than P2, the collision probability for the closer guys to be larger than the further guys, and we are saying this specific hash family that you can get by taking a Gaussian vector at random, converting your high dimension to a single dimension and adding a uniform value b to it, dividing by w and then taking a floor. That family of hash functions has this property. In practice, you want the separation to be large, right. So, that's where the practice problem comes into picture, right. So, P1 and P2 separation, you want P1 to be like 0.8, P2 to be 0.1, right. So, but in practice, to achieve that, you cannot just use this family as such, but then we can use this family as a building block and then construct a nice hash function, which is the LSH hash function in its full glory. That we will see next time, and then we will also understand how to compute this width w and what kind of parameters that we need to tune in practice. But we have the heart in place, right. So, we have found the main idea here, and then we will use this as building blocks to come up with the full-fledged LSH function next time. Thank you.